Okay, let's work some problems here that this type of problem will occur on the exam. So let's see. What if we had sine of, let's make something up, 9x times cosine of 5x. So there's a formula we have for this. It says sine of x times cosine of x, or cosine of y, I should say, equals 1/2 sine of x plus y plus sine of x minus y. So in this case, it's going to be 1/2 times sine of 9x plus 5x plus, I'll put a bracket there, plus sine of 9x minus 5x. So it's 1/2 sine of 14x plus sine, I'm going to run out of space here, 4x. And that's how you do a problem like that. Now let's try another one. What if we had sine of, make up another number, 35 degrees times cosine of 26 degrees plus cosine of 35 degrees times sine of 26 degrees. So what does this look like? This looks like a sum of two angles. So it'd be like sine of x plus y is sine of x cosine of y plus cosine of x sine of y. So this just must be sine of 35 degrees plus 26 degrees, which is sine of 35 and 26, 61 degrees. If you want to evaluate that, we take out our handy dandy calculator and do, let's see, make sure my calculator is in degree mode. I'll do sine of 61 degrees is 0.8746. Okay, that was fun. Let's find another problem to do. Okay. Let's see what this says. It says, if cosine of alpha is a certain number and cosine of beta is a certain number, we want to find cosine of alpha plus beta and cosine of alpha minus beta. So I'm going to clear the screen so we have room to work. So let me see if I do this. Does this erase it all? Delete. Hey, look at that. Okay. So I'm just going to make up a number. Cosine of alpha equals 0.251 and cosine of beta equals 0.372. And we want to find cosine of alpha plus beta and cosine of alpha minus beta. So in the alpha plus, oh, yeah, it's recording. In the cosine alpha plus beta is cosine of alpha, cosine of beta, and we have those two, but then we have a minus sine of alpha, sine of beta. And then the cosine of alpha minus beta, it's cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. So what are we missing? Anyone know what we're missing? That's right, we're missing sine of alpha and sine of beta. So when we see a problem set up like this, as opposed to the next problem we're going to do, I mean, we could just do the triangle thing too. We're told these are first quadrant angles. So you could then just go with cosine inverse of 0.251 equals alpha. And then we're going to find sine of alpha is going to be sine of cosine inverse of 0.251. And we'll get that answer. And then we'll have cosine inverse of 0.372 equals beta. So that sine of beta is sine of cosine inverse of 0.372. So let's see what we get for each of these. Once again, I turn to my calculator. And this wouldn't really matter if you're in degrees or radians, because we're not actually going to be putting those the angles in. We're just getting the sine of these particular angles, alpha and beta. So I'm going to do sine of cosine inverse of 0.251. And I get 0.96. And they went to 3 places, so I'll go to 3 places, 968. And then sine of cosine inverse of 0.372. And I'll go 3 places here again, 0.928. So cosine of alpha plus beta would be cosine of alpha, which is 0.251, times, oh, that fell out of the parenthesis, times cosine of beta, which is 0.372. And then we have minus sine of alpha, which is 0.968, times sine of beta, which is 0.928. What do we get? So 0.251 times 0.372 minus 0.968 times 0.928. I get negative 0.80, I'll round to 3 places, 805. And then cosine of alpha minus beta is going to be our 0.251 times 0.372, and plus 0.968 times 0.928. Okay, and the nice thing about the TI-84 is I can bring down that last expression I put in there, and it might change that minus to a plus, and I get 0.992 if I go to 3 places. And that's it. Wasn't that fun? I'm glad you agree. Okay. Let's keep moving on. Oh, I could just scroll down the page. Okay, the next one. We have cosecant x equals (18/15). And that's in quadrant 1. We want to find sine of 2x. So sine 2x is equal to 2 times sine of x cosine of x. So we already have an idea of what sine of x is. So since sine of x is 1 over cosecant x, that's 1 over 18 over 15, or 15 over 18. To get cosine of x, we will use the information we know. The opposite side, sine is opposite over hypotenuse, so we have 15 over 18. And we want to find this a. So a squared plus 15 squared equals 18 squared. A squared equals 18 squared minus 15 squared. So a squared is what? I get 99. So a would be the square root of 99. Since we're saying it's first quadrant, it'll just be positive. So that'd be square root of 99. So sine of 2x is going to be 2 times sine of x, which is 15 over 18, times cosine of x, which is the square root of 99, the adjacent side, over 18, the hypotenuse. So we end up with, let's see, I think I can reduce some. So I do have this 18 down below. Then on top I have a 2 times 5 is 30. The 99, 9's a factor. So you have the square root of 9 times 11. So you end up with the square root, so 30 times 3. Oh, that's 18 squared, by the way. Times the square root of 11. Starting to panic there. I'm like, how could a sine be more than 1? And 18 squared is what, 324? Yep. So this, that will have a 90. So 90 times the square root of 11 over 324. And I can factor out of 90 an 18. So 90 divided by 18 is what, 5? So we have 18 times 5 times the square root of 11 over, and then 324 is just 18 times 18. So that divides out, and we have 5 times the square root of 11 over 18. And that's it. Okay. Okay, now we have another one that's going to look like a product. Right, a product is a sum or difference. So let's see. We'll have 15 times sine of 22q times cosine of 12q. And our formula for that, so it's a sine times a cosine. When we have a sine of x times a cosine of a y, we saw this earlier, it's going to be 1/2 times sine of x plus y plus sine of x minus y. So this will be 1/2 times the 15, or I could do 15 times 1/2, times sine of 22q plus 12q plus sine of 22q minus 12q. So I end up with 15 over 2 times sine of 34q plus sine of 10q. Okay, fun stuff, huh? Now we're going to do a sum to a product. So in a sum to a product, let's see, here's the problem we have. We have sine of, no, we could just go with the same kind of numbers we had, 22q plus sine of 12q. So just remember in our formulas, sine of x plus sine of y is going to be 2 times sine of x plus y over 2. So this is the stuff inside the sine is over 2 times cosine of x minus y over 2. So what do we have? We have 2 times sine of 22q plus 12q over 2 times cosine of 22q minus 12q over 2. 2 times sine of 22 plus 12 is 34, divided by 2 is 17q. Cosine of 22 minus 12 is 10, divided by 2 makes that 5q. That's it. Let's see, let me get another page out of this. No, don't want to highlight it. Just want to go to the next page. Okay. Oh, great. Guess that's what I did. Oh, we'll back up here. Let's see. What do we have next? Here we go. We're going to find, this is a half angle formula, find sine of u over 2 if cosecant of u over 2, sorry, of just u, equals 4.75. And u is in quadrant 2. So this is a half angle formula. And our half angle formulas do what? Sine of x over 2 equals plus or minus the square root of 1 minus cosine of x over 2. Now, this is in quadrant 2, so half of that would have to be quadrant 1. So u over 2 is quadrant 1. Okay, now what else do we know about this? And it's going to be cosine that we're dealing with. So being in quadrant 1, it'll be positive, and we're given cosecant. So 1 over cosecant of u must be sine of u. So sine of u is 1 over 4.75. So sine of u would be, get my handy dandy calculator around here, 1 divided by 4.75, 0.2105. Now, u must be sine inverse of 0.2105. And if you notice from, where's my tools for writing? I wanted to change colors. But if you notice, we're talking about a cosine here. So cosine of the angle, cosine of u is cosine of sine inverse of 0.2105. What's that going to be? I'm going to get 0.9776 if I round to 4 places. So that lets us say then sine of x over 2 is going to be the positive square root, positive because it's first quadrant, 1 minus, and cosine of that angle is 0.9776 all over 2. So it's going to be the square root of so I have 1 minus 0.9776 divided by 2. I'm getting 0.0122, which would be I should say approximately 0.1058 if I round to 3 or 4 places. Okay, well, seems like a lot of fun so far. Kind of wish I was a student taking this test. Next one. It says write the product as a sum or difference. So we will have 6 times cosine of 22b times cosine of 10b. So what's our formula for a cosine times a cosine? Well, cosine of x times cosine of y is 1/2 of cosine of x minus y plus cosine of x plus y. So this would be 6 times the 1/2 times cosine of 22b plus, or that was minus in the beginning, minus 10b, really doesn't matter because addition is commutative, plus cosine of 22b plus 10b. So it's 3 times cosine of 12b plus cosine of 32b. That's it. Oh, I found my colors again. Okay. Moving on to the next one. So now we're going to simplify the following. Cosecant x times tangent x. So cosecant of x is 1 over sine of x. Tangent x is sine of x over cosine of x. So these divide out. You get 1 over cosine of x, which is secant x. Is that fun? Now let's try another one. We have, oh, it's an equation to solve. We like equations to solve. So I have 3 times cotangent of 3x equals the square root of 3. So the first thing I do is get this cotangent by itself. So I divide both sides by 3. I have cotangent of 3x equals square root of 3 over 3. So 3x is equal to cotangent inverse of square root of 3 over 3. Now, I'm reading this, it says it wants all the solutions from 0 to 2 pi. So we have to think to ourselves, when is cotangent inverse going to be, or when's cotangent going to be square root of 3 over 3? Or cotangent inverse of square root of 3 over 3 is what? So if we recall, all students take calculus, this is the quadrant where it's also positive, the third quadrant, and then this quadrant. So if you look in your chart, or you've memorized it because I've asked you all to memorize it, we know that there are two values, one from the first quadrant. In fact, actually, we're going to have to look at this multiple times because of the 3x. Because it's 3 times around. If you don't look at the 3 times it can be, you're going to be in trouble. You'll get 2 solutions out of what might be 6. Okay, so this is going to occur at pi over 3, and then it'll occur, that's the first quadrant, then it's going to occur at the third quadrant, so that's going to be 4 pi over 3. Okay. Now, that's the first time around. Now, because of the 3x, we have to go 3 times around. Then it's going to occur, so it's here, and it's going to be here. So it's going to occur up here at pi plus pi over 3. So that's going to be, what, 7 pi over 3? So 7 pi over 3. It's going to occur all the way down here again. So that's at pi, no, I should say not 7 pi over 3. It should be 2 pi plus pi over 3, which is 7 pi over 3. So 2 pi plus the 4 pi over 3. What would that be? What's 2 pi plus 4 pi over 3? That's like saying 6 pi over 3 plus 4 pi over 3 to give us 10 pi over 3. So it'll occur at 10 pi over 3. So I don't know if you see a pattern yet. It looks like it goes from pi over 3 to 4 pi over 3 to 7 pi over 3 to 10 pi over 3. Looks to me like it's increasing by 3 pi over 3 each time, which actually makes sense. So if we continue that pattern, it would then be 13 pi over 3 and then 16 pi over 3. Now this is not the final answer. In fact, if you put this in, it'll be wrong. So what we have is that 3x equals pi over 3. So if we multiply by 1/3, we have x equals pi over 9. Then we have x equals 4 pi over 3, 3x, excuse me. If we multiply that by 1/3, we would have x equals 4 pi over 9. Then we'll have 3x equals 7 pi over 3. Then we multiply by 1/3. X would be, you see a pattern yet? 7 pi over 9. And by the same process, we'll have x equals 10 pi over 9, 13 pi over 9, and 16 pi over 9. So that should give us all the values. Just to point out, 18 pi over 9 is 2 pi, so that would give us a full circle. So we're just shy of that 2 pi mark. So that is 1, 2, 3, 4, 5, 6 answers. So again, if you recall, you can always play this over again. We memorized the first 2 answers because they're in the third quadrant, so we know those. But because it's 3x, we have to go around 3 times because we're going to be dividing that back down. Okay. We have one more fun-filled problem to look at. Let's look at that now. Oh, what a good problem this is. I need to clear some space off, so let's just do insert maybe a blank page. There you go. And we go back to draw. So we have cosine squared x plus 9 sine x equals negative 9. All right. I'm going slow on this because I'm trying to make something up as I go along. So I want to make sure this is going to work. Now, we have a cosine and a sine, and we need to have them be the same thing. In fact, let me do those in a different color. We need these to be the same function. And it's really hard to change a sine, but it's not as hard to change a cosine. So cosine can be written as 1 cosine squared. Sorry. It's hard to change a sine. It's not hard to change a cosine squared. It's not hard to change a sine squared either. So 1 minus sine squared x plus 9 sine x equals negative 9. And then we add 9 to all the parts, or both parts. So then it'll have 10 minus sine squared x plus 9 equals 0. And I like to write that as negative sine squared x. Oh, that was 9 sine, by the way. Negative sine squared x plus 9 sine x plus 10 equals 0. And I don't like the looks of that, so I'm just going to divide everything by negative 1 to change the sign. And we have sine squared x minus 9 sine x minus 10 equals 0. Now we can say u equals sine x. So u squared minus 9u minus 10 equals 0. We do that substitution. You don't have to do it if you don't want, but sometimes it's easier to see this with a variable instead of a trig function. So that tells us that we have u minus 10, if you factor this down, as a factor, and then u plus 1 as a factor. So u minus 10 equals 0, means u equals 10. U minus 1 equals 0 means u equals, that's u plus 1, u equals negative 1. So we're not finished. That's just getting this down to this point. But we have to ask what was u. So we say sine of x equals 10. So if I said sine inverse of 10 equals what? Well, that's not possible. Does not exist. Because sine can't produce something as big as 10. The most sine can produce is 1, and the smallest sine can produce is negative 1. So now let's look at this next one. Sine of x equals negative 1. Hey, I just said that's the smallest thing it can produce. So if I said sine inverse of negative 1 equals what? Everyone shouts in unison, 3 pi over 2. So it wants us to give all the solutions. So our solution would be 3 pi over 2 plus 2 pi, and they say use k as our generator, 2 pi k that generates all those infinite number solutions. Or you could say negative pi over 2 plus 2 pi k. But I probably would have just gone with this one. Okay, that's what I have for the test plus the stuff we did in class. So I hope that helps you to feel more prepared for this exam. And I wish you all good luck. If you have any issues, you can reach out to me. And I plan to have some extra office hours on Thursday of the week that I'm making this video. So if you're watching this not when it was first published, then I'm probably not having office hours on that Thursday. But so, okay. Good luck, everyone. I will talk to you soon.